We would like to know if the sequence n squared times e to the negative n converge or diverge. Therefore, let's go ahead and take our limit as n goes to infinity to see what happens. And before we do that, let's rewrite an as n squared on the top. We have e to the negative n. We can write that as over e to the positive n. And let's take the limit in our head first. As n goes to infinity, we have infinity squared, which will be infinity. And then we will have e to the infinity. That will be infinity as well. We will have an infinity over infinity situation, and we should use L'Hopital's rule. And to do L'Hopital's rule, it requires derivative, right? We cannot do derivative with n, so therefore we are going to change the letter a little bit to be more legitimate. So I will say as x goes to infinity, and I will look at this expression, I will change this into function with x. Let's look at x squared over e to the x. I would like to know what will this approach to. Well, to do L'Hopital's rule, let's go ahead and differentiate the top and differentiate the denominator. And then this is by L'Hopital's rule. I'm just showing the work. On the numerator, the derivative of x squared, it needs no introduction, it's just 2x. And then on the bottom, it's just e to the x, right? And then if x goes to infinity, we will still have infinity on the top and then infinity on the bottom. And let's go ahead and do L'Hopital's rule again. And then we'll just take the derivative of 2x, and we get 2. And then derivative of e to the x will be just still e to the x, right? And perhaps I should show you guys the work. We are taking derivative on the top and derivative on the bottom. That's how we get the 2 over e to the x. And now what? Should we take the derivative of this again? We should not, because on the top it's just a 2. On the bottom, as x goes to infinity, we will get 2 over e to the infinity. Do not differentiate this anymore, okay? Do not differentiate this again. Because we don't have the right, we can only use L'Hopital's rule if it's infinity over infinity, okay? You cannot say differentiating 2 and then you get 0, the whole thing is 0. It doesn't work like that. All right, we can continue with this. 2 is always on the top. And then e to the infinity will still be infinity. So that's the infinity right here. And 2 over infinity, we can draw a conclusion. This is 0. So this right here is the limit. And 0 is a finite number. Therefore, we can say this sequence converges. And if it converges for limit, that's pretty much the answer right here. It converges to the number that we got, the 0. So the sequence converges to 0. That's it.